So I work for Exploristics, which is a small company in Belfast, primarily working with clinical trials. The software development team is quite a small team, probably only about 10 of us, so we're a small team within that. And Exploristics as an organization has about 70 staff. So the title of my talk is Seamlessly Integrating Shiny Applications into KerusCloud. And KerusCloud is our flagship application that develops clinical trials. That's on the AWS, Amazon Web Services, and it simulates clinical trials, sort of a decision support tool. And I'm going to talk about how we integrate Shiny within that. The first thing I would like to do is change the name of my talk, which is an interesting start. So the communication people, they wanted that word seamlessly in, but as developers, we all know it's anything but seamless. So hopefully as I go through, I'll be talking about the actual, how we've aimed to make that seamless for the user. So from a user perspective, it wants to be seamless integration within this ecosystem, and it hasn't always been that case. So just want to talk a little bit about that experience, and like Colin was saying, sort of the warts of that process, so won't present it too much, but won't present too much warts as I'm going through. And I'll give 2 demos along the way. So what we'll be talking about is the use cases that we have for Shiny, and the use case 1 and 2 are the one application. So this application is called the Data Model Builder, and that was what Carissa was talking about. We had a project from Innovate UK funded with Jumping Rivers, and to take this application from a proof of concept and into a minimal viable product, and we were helped with the cloud infrastructure, and a lot of the team in Exploristics helped it, or the team in Jumping Rivers helped take that forward. And then we've took that further forward. We've kind of had the problem that people have alluded to earlier. It's a minimum viable product. Then the sort of business heads within the organization wanted to get that in front of commercial people to make money, and the developers are panicking because we want to put in more validation and make it more robust and scalable. So those sort of issues that occur, but not just the technical ones that I'll talk about, but I'll also talk about the technical issues. And then the third use case was an application that we developed. It was a data visualization application that's embedded within Kerus. And it used to be previously, we used Tableau, but then we wanted to go to Shiny, and I'll talk about the reasons why we went from Tableau to Shiny and the use case for us. Might not be for everyone, but this is just a use case that we had for it. So first of all, I'll just talk a little bit about my background, just to try and set the scene a little bit. So I am from a sort of research, more academic background. I'm not not a degree in computer science by trade. And I think the R program, that's very common from my experience in that pipeline. And you don't have that developer skill set to set out with. I've wrote some really bad code to start off with when I look back. That sort of desktop application that you're doing for a one-off report or study, and then you think, oh, I would like to wrap this in an application. And that was a real part of my sort of career goals and paths. And I just wanted to briefly talk about that a little bit, and sort of how I dealt with that, going from that sort of research role to that. So just like many people, self-taught in R, and it was really useful. I'd done a PhD in 2012, and there was this proprietary software. You couldn't get access to it. You could only do that, so the sort of an analysis that they gave you. Then I started doing data analytic work, and I was using the sort of copying and pasting, that horrible, like Chris was talking about earlier, in Excel. I was that person at one stage, so you have to forgive me for that in the past. But then going forward, I wanted to use R, because using larger and larger data sets, and these data required that sort of R, the programming tasks. And the natural progression was then, well, I'm creating these resources. I want to develop Shiny applications for people to use. And then I wrote the Shiny code, and I was developing these applications, but there was nowhere to put it, and that was the R in production. So I had this Shiny code, didn't have dependency management that Andrew was talking about, but the code was going somewhere. And the picture I've chose here is just, I know there's a lot of runners in the room, but it was also about an analogy for the learning curve of R. I found that it wasn't like sort of slow, progressive one. With R, when you're learning new concepts, it's really steep learning curve, almost like a cliff. Like that reactivity in R, I found really difficult. It's like, what is going on? And then one day, everything just clicks, and it's like getting to that, plateau you're above, and you have a really nice view, and you're like, oh, this is really, really good. And then you don't want to look behind you, because there's probably another cliff of something you don't understand. So just enjoy that view when you came over that plateau was just the advice that I wanted to say. Now I'm just going to provide a little bit of background about KerusCloud. So this sets the scene for the Shiny apps and why we integrate them. I don't want to go into too much detail, but just the real take-home message as to why we use Shiny apps and how it integrates in just makes a little bit more sense. So like I said, don't expect to take everything in, but just trying to set the scene. So KerusCloud it's a cloud-based application, as the name says, so you can run it on a browser. Any people can use it to develop clinical trial simulations. It's sort of a decision support tool. And what that looks like in a technical sense, so it's a web application, so the front end is developed in Angular. And you can see here we use other technologies, and Docker that was talked about earlier. And Shiny, what we use it for is embedding it within the application as an iframe, and I'll show you what that looks like, just a screenshot later. It's Docker, Dockerize Shiny. But we also have standalone applications that exist outside that, and they integrate with Keras, so sort of communicating and passing information to it. The middle tier is we use AWS, so that's Amazon Web Services, is our cloud provider. Also have PostgreSQL. So when I was going from that sort of desktop analysis, you only had one session. The user could carry out something, and then it was effectively lost. So that's sort of new concepts. It's storing this information in SQL databases so you could retrieve it, and the user could retrieve projects that they previously worked on and amend. So that's just something in terms of my learning experiences going through. And then the actual simulation engine is written in R, so that's R6, just a form of object-oriented programming within R, if no one's familiar with R6. And just a little bit about the clinical trials, again, just to set the scene. In Keras, what you have to do is define a variable. So that could be something, just to provide an example, something like height. And then height will have a distribution, so it's obviously like something like height would be normal. So that would be, if you think back to your class, in school, most people were average height, some people were big and some people were small. So that's a normal distribution. Keras allows you to define other distributions, like we'll all be familiar with exponential growth from COVID, but there's multiple distributions that Keras lets you define. But to actually simulate that, you need some information to inform the model. And for the example of a normal distribution, that's a mean and standard deviation. We go a little bit deeper. If you think of like a bimodal distribution in Keras, we would define this as something that has layers. So the example of height, you could have it, males might be taller than females. So that's something that we have. And then we'll go into like correlations and have general additive models, and we'll have lots of things that build upon this. But the sort of take-home message is that it's a dynamic thing that the user generates, and we want to then simulate it, analyze it, and optimize clinical trials based upon the information that we're simulating and where we use Shiny within that framework. So just to show you, this is what Keras looks like, just the UI, or the user interface, sorry. And where the actual interface itself isn't Shiny. This is the Angular interface, but where the Shiny is within, it's within these two view buttons here. And when we go in, so it's just trying to have that integrated user experience. It's it's put as an iframe. So the iframe is effectively the Shiny application, which I'll show you later, is this box here. And we wanted to share that login. You want to have a single login for the user experience, and just go through, click on that application, and see those visualizations to make those sort of informed decisions. And here's just the link if you wanted a little bit more information, if anyone's interested in clinical trials. I'm not going to go into it today, but I was just wanting to provide a link if anyone wants to do it on the Exploristics website. So the first use case I'm going to talk about is the data model builder. So this is the application that we worked with Jumping Rivers, in terms of taking it from a prototype through to the actual sort of in production. I'll just talk a little bit about the actual cloud infrastructure. This slide, I spoke to our developer about this for an hour and a half, so I'm not going to go into any detail, but there's some interesting stuff about what we were talking to earlier on about Docker. So we store our code in GitHub, and this triggers a build where the application's built. It's Dockerized, and so when we were talking about, when Andrew was talking about that earlier, just to point it to you, in AWS, each of these icons is what's known as a resource, and the initial, the full schematic has 47 resources. So when you're using tools like shinyapps.io and Shiny Connect, it's effectively taking care of a lot of this for you. But if you want custom functionality, this is why we use AWS. And the reason why we use AWS is to do with security and also the user experience. So we deal with clinical trial information, which is obviously highly sensitive, and we want it within that contained environment, but we also want to communicate within that. We want to pass information from the data model builder to Keras, and we don't want to do that with any sort of external links and potential vulnerabilities. And that's Cognito is the authentication service. And what that also allows us to do is pass the information between and have that security. just some of the things in terms of going from that sort of desktop, but I wanted to talk about to go into production. The load balancer, it effectively communicates with the application. And again, I'm not going into too much detail of this, I can go forward. But what we found when we went to production, by default, AWS load balancer will ping the application every 10 seconds and expect a response, just a simple response to make sure the application hasn't crashed. Within our application, it was running perfectly on the desktop, and went to the cloud, just started crashing, we couldn't figure it out. What happens here, the load balancer does that ping every 10 seconds. If it gets three non-responses in a row, it assumes something's went wrong with the application and shuts down. The data set that we used, our models took roughly 30 seconds to build. So what that meant was sometimes when we loaded the data, and depending upon when we hit the build button, you might have got 2 negatives and then a positive, and sometimes you got 3, and it was just tearing your hair out trying to wonder, it's the same data set. The initial sort of, because it was only a proof of concept, how we fixed this first of all, was change that 10 seconds up to 60 seconds. But going forward, we're going to look at sort of asynchronous programming. So that's just sort of the issues that you might face when you go from, this sort of, it works on my desktop and you're going to the cloud and tearing your hair out because it's in a different environment. So that was just a really interesting problem that I thought would be interesting to share with the room. So now I'm just going to demo the applications, which says never demo anything. One of the things I've learned from this is that you're allowed to record videos of it, and next time I have one, I'll have a recording. The interesting thing as well, I was speaking to my colleague Danny, was we're talking about a conference about Shiny in production. We have these applications in production with a web link. So you're probably wondering why am I doing it the desktop application. Just to explain that little bit of irony, is because the Cognito service, what it'll often do is it'll take care of a lot of like fraudulent cases. So I always log on from Belfast. Suddenly I'm logging on in public Wi-Fi in Newcastle. Not saying anything's dodgy about Newcastle, but so it might trigger and say suspend my account. And the last thing I want to happen is just before demo, my account gets suspended. So that's just some interesting things that will also happen when you're using those sort of services. But just in terms of talking about the data model builder, just real briefly what it's supposed to do, it takes a patient level data set and transforms it using a sort of feature extraction and some algorithms into something that Kerus can use. So if you think when I was talking earlier about a distribution, it takes a data set, gets the variable, says this is a normal distribution, and then gets those parameters. In this case, it'll be mean and standard deviation. So it's automating a lot of that process, and then looking at the layers, whether it's like defined by, in our terminology, biological sex. So it would have 2 what we define as layers there. So it's doing a lot of this data wrangling, and then automatically importing it into Kerus. So it's improving the user experience. You don't have to type that information in. So that was the goal of it. So just to talk a little bit about that, it was communicating then via an API. So it's passing information from the data model builder to Kerus in a JSON format, and then storing it in the database. The problem we often encountered then was about validation. Because we were using an API, that meant the Kerus interface had validation within it that stopped the user entering invalid information. So for example, you can't enter a negative standard deviation, for example, things like that. It's unlikely that the application, the optimization process would come back with a negative standard deviation, but we're bypassing that information, but just to give you an example. But we also had validation on project labels, for example. For this one, we have a project label, and we don't want it to start with the protected symbol $ within Kerus. Previously, in the first iteration of the data model builder, you could just type whatever you wanted, but now we've used a really useful package, which is Shiny validators, and this gives real-time information. So if I type in that, $, which is previously only on the Kerus UI, and we could bypass this and put in syntactically invalid information. And what would have previously happened is it might have transferred through the model built, transfers through to Kerus. People set up their simulation, go to run their simulation, and then it crashes. And those steps can take maybe 20, 15 minutes, when really the problem is something really simple down the line. So this is really important when you're going into production, to provide that real-time feedback to users so they can do something sensible with this. In this case, just change the name. It's a bit longer. So that validation occurs there. Just going to, on this screen, just going to upload some data. I'm going to upload this data. This, again, like I was saying, this is just a patient-level data set. and just displaying using the data table package here, or DT package. We're not displaying it here, but we've also used in other applications some custom JavaScript to click within this. That it's really useful, so we could then drill down into individual rows and have selectors within that. Just wanted to highlight that, and we'll have in a different application, but I don't have it here. So then we're just going through, again, lots of widgets here. Like everyone else is kind of wary of using widgets now. Hopefully I haven't used too much. And we're just building the model. And this is just carrying out that process that the user might have had to do manually, go in each variable, define the distribution, calculate the parameters for them. And it's displaying this information to the user. Just to talk a little bit about the things that we experienced going through this. I think people alluded to it earlier about the complexity from the developer versus the complexity for the user. And our users were always pushing for, like, oh, we want more things, we want more things. And that puts that developer complexity. Within this application, I had a lot of difficulty with these dropdowns because they cascade through an update. As I change one, it cascades through to update that, to update each variable, which is really nice for the user because when they change that, because not all the options might be valid for each distribution. And then the plots update as you do it. That becomes really complex because there's a cascading chain where when this updates, it wants to plot, but then this cascading update and this updates this, which wants to plot that, which then updates this, wants to plot that. And there's a function called freeze reactive values that does that. The better case, which I'm probably going to implement, is a button to plot it, just to save that computational time, because it also involved that there's this transient state, whereas if I was to define a binomial and then it was to be defined by, in this case, of have a sex, it might be a case if I had the previous one was still sex, it wouldn't be able to select that information because it doesn't exist, and the application was crashing and being really buggy because that. It was also having this jittery plot effect. So that's just some things to think about when you're developing an application. Like I was guilty of it too as well, but a lot of our, the people within the team were just wanting like that functionality, and users will always ask for that, the functionality. So that's the application, or that. And we'll have a simple review page. The review page just shows you information about the sort of model that you've built. So it's just a summary, and then we're passing this information to Kerus via this button, which does it via, as I said earlier, an API. And you also need to, that's why we needed to have it within the same virtual environment in Amazon Web Services, which sort of we chose to go down that route. So then, as a user, the data model builder knows who you are. It's passed into Kerus, doing the security authentication. But then within Kerus, when you log in at another time, it also needs to know who you are to retrieve your projects. So that's important things. And like I say, these are sort of new concepts to me, going from that desktop analysis. So that was some things that I needed to take in. And going forward, like it's a really sort of nice stage to be presenting about this. I just wanted to talk a little bit about, I know there was a blog post from Jumping Rivers, haven't read it yet, about refactoring code. I've recently just refactored the data model builder, the server code, and anyone who's Shiny developers in the room will feel with me here. Server code was about 1,500 lines long, didn't have much modularization. It was really difficult to deal with and debug and scale. I'm coming up to this conference, I thought really motivated. It's like, I'm going to a Shiny in production conference. I'll do the Shiny modules. And I got the server code down from 1,500 down to under 150 lines. So it was just like a real positive benefit. And it makes the code easier. The reactive chain is easier to debug on, and it's going to make it easier, because we're going to have that. The business heads in the organization are going to want new features, and it's going to make implementing those new features relatively easier. The reactivity chain was, spaghetti reactivity. It was triggering too much, and it was really difficult to actually figure out what was going on. And that was pressure. That was that kind of pressure from going from, it's a proof of concept. It does what it's meant to do, and now it does it for that one data set. Now they want to roll out to as much customers as possible, and they're the sorts of things, make it scalable and robust, that we didn't do for the proof of concept, because we're trying to get that as quickly as possible for the purposes of a grant. So those are sorts of things that you'll encounter, and I suppose it's not a technical issue, it's a people issue, isn't it? Now I'll talk a little bit about so this is our visualization apps within Kerus. So this is the one that was embedded within an iframe. Again, I don't expect anyone to know all the details within this. Just to quickly say that what these numbers mean, it's the probability of success of your clinical trial based upon what the users defined in. So there's a lot of information here in which there's a lot of information to take in, which is why we used the heat map. Initially, we had used Tableau, and Tableau can display this sort of level of information. But as I go forward, I'll sort of show you some of the functionality that the Tableau didn't carry out. And what I wanted to talk about was this little widget here. So, Colin, I'm sorry that I have this widget, but I have some good news. It's for accessibility. So we have a member within the team who has red-green color blindness. So every time we're developing applications, and Colin's already talked a lot about accessibility, but that just emphasizes why it's important to have diversity within your team. We then now have someone who has red-green color blindness and provided us with that feedback. I know, and Colin had said about the tools that do that for you, so I'm really interested in seeing what they look like and using them. So that's just a point about the sort of accessibility. So just to talk a little bit more about the information. So this is a decision support tool. So that on a sort of business level, the sort of pharma companies can then make decisions based upon this. They'll evaluate lots of different sort of potential scenarios for their clinical trial that will be simulated virtually, and then it allows them to sort of assess what risk they're wanting to do. But if I click in then, so the functionality in this particular plot, we'll have hoverovers, because there's lots of information that to drill down. That number doesn't mean enough for itself. There's lots of different scenarios that clients often want to come to us. What happens if X happens? And then they often ask, well, what happens if Y happens? And what happens if this? So Kerus allows that really iterative way in evaluating all those sort of potential scenarios to allow sort of decision support process. Previously, in the sort of workflow that a lot of people had done, the statisticians, you would have done scenario X, looked at it, done scenario Y, looked at it, and then sort of tinker with it. What Kerus does is sort of simultaneously easily allow you to do these iterative approaches and look at lots and lots of different complex scenarios. I suppose one of the downside is it generates lots and lots of data, and how you then want to get that into some sort of information to allow someone to make actionable results. Tableau worked. We used Tableau previously for this heat map, but what we were finding is, well, clients were often asking for additional information about that. Well, that 100, what's it built on? What's the assumptions? And drill down within it. So this uses the, I've been struggling to pronounce this the past couple of days, giraffe package, and allows us to drill down. I'll just show the sort of functionality within it. So if I click on an individual plot, that just brings us in to that cell within it to provide some more information. Again, I don't expect everyone to know what that information is, but the real message I'm wanting to try and get across here is it's a decision support tool that allows the business business people to make business decisions upon their clinical trials. But if I look at a different plot, this one, for example, it's a different type of analysis, and what that means was we get different plots. So Tableau really struggled with that level of sort of dynamicism. So what we're seeing here is a different plot. And this is a form of clinical trial. It's called an adaptive design. And it's just to try and just show you what some of the statistics mean rather than just throwing up graphs in front of you. An adaptive design is when you make a decision part of the way through the process at an interim time and decide whether you want to have, you can have have less patients within that, but that's defined on your probability of success. And what will often happen is you could probably drop your number of patients and your probability of success is going to go down. But that's a cost-benefit analysis, and what this decision support tool is allowing people to inform those by data-driven decisions and de-risk the project. And sort of there's some other nice functionality. In the giraffe here, you can go hover over them and it highlights all the other ones. So that's just the sort of functionality that our clients were wanting that the Tableau package wasn't quite performing with. And one of the other issues that we had with Tableau was also the cost. So we had to maintain the servers. What we were finding is for each user, we had to have a particular license. And we also then, because we work in the production environment, the development environment, and have around 10 developers to do that, we might have, that's a lot of licenses and a lot of cost, and maintaining that cost was difficult for us. And that was why we wanted to choose Shiny. And I think that is all I have to say. I just wanted to show those applications, just wanted to finish up. just by thanking Jumping Rivers and everyone for attending today, and the feedback and the discussions that I've had with everyone. It's been a really good conference, and I've really enjoyed it. It's my first time at a conference like this, so I've really gained a lot and learned from it. So just thank you all.